Hello and welcome back. In this video we will be using logarithms to try to solve for time in investment. One thing that we've seen before is if we invest into account where it is compounded continuously. So every cent that you would earn gets added immediately back into the account so that that 1 cent will begin to earn interest, so you earn interest faster and faster and faster. We have this formula here. So the money in the account, which is given by A, is going to be equal to the initial principal, so how much we initially invest, times E raised to the interest rate, which is the APR, times how long you invested. So there's 3 things that we would have to know to find how much money will be in our account. We need to know how much we initially invest, what's the interest rate, and how long we have invested for. But I could also ask a different sort of question. If I told you how much I initially invest, what my interest rate is, and how much money I want in the account, we could try to figure out how long we should invest for. So maybe I want to double how much money I have in my account. How many years would it take for the money to double? So we would just have to solve for y here. And so let me do a specific example where I try this. Let's say that we invest $1,000 at 5% APR compounded continuously. So right away we know our principal is $1,000. Our APR, APR is going to be 5%, which written as a number is going to be 0.05. And then how many years will it take to have $1,500 in the account? So the account was going to be $1,500. And the question is, how long would it take? How many years would we have to invest for? Well, we can plug all these numbers into our formula. And our formula is A is equal to P times E to the APR times Y. So we have A is going to be 15,000. P is going to be 1,000. And we've got E, which is going to be raised to the 0.05 times Y. Now the thing is, y is up here in the exponent, and we need to bring it down out of the exponent. And we don't have necessarily a quick way of doing that with multiplication or division. In our last lesson, we learned about logarithms, and logarithms are what we use to bring an exponent down so that we can actually solve for it. So let's review logarithms. So if we have something raised to a power, I can use a logarithm to undo raising it to a power. And the way this works is I'm trying to figure out what that power is. So I know that y is going to be equal to something. And as the name suggests, we're going to use a logarithm. One thing to keep in mind is that b here is what's called the base of the exponent. We're taking b raised to a power, so b is the base here. So b should be the base of this logarithm as well. This is log base b of a, the only other number in here. So if we have an exponential, if we have something raised to a power and that's equal to something, I can solve for that power by using a logarithm. So let's see how that works with this equation down here. First thing to notice is that I don't just have an exponential. I'm taking this exponential times p. So in order to make it look like this, I want to move the p to the other side. So first things first, I want to divide both sides by p in order to undo multiplication. Again, p is multiplying the exponential. I don't want it there. The way to undo multiplication is to divide. So this is going to be a divided by p is equal to e to the APR times y. Now I have an exponential just by itself. I can use my logarithm. So again, the way the logarithm works is I will be able to take the logarithm of both sides. What will happen is my power, I will have solved for my power. So I will know that the exponent up here, which is APR times y, is going to be equal to, well, e is my base, so I'm going to have the log base e of the only thing that's left, a over p. And I'm nearly done, because I just wanted to solve for y, right? Well, y is being multiplied by the interest rate. So in order to undo multiplication, I divide. And after I cancel out my APR, I'm just left with y is going to be equal to this mess on this side. But this is something that a calculator can handle. So here is the formula for time when we are continuously compounding interest. The one thing to notice here is that I have log base e, and most calculators that you'll come across won't have a log base e function. There's no button to press that says log base e. However, log base e shows up so much that mathematicians have given it a separate name, and it is called ln, which stands for natural log, or natural logarithm. And it's because e shows up in so many equations across so many fields, whether it's finance or engineering or really any branch of science. E shows up so often that log base e is given a special name. So it's called ln, or the natural logarithm. So if I were to write this in terms of the natural log, this is going to be y, how many years we invest, is going to be the natural log of a divided by p, all divided by the annual percentage rate. ln will be found on most scientific calculators, including Desmos. So I'll show you how to do that in the next problem. So we invest $300 at 2.7 APR, compounded continuously. So how long would it take to earn $20? How long would it take to double our investment? How long would it take to triple our investment? And I'll just say we'll round to the 10th place. There's one place past the decimal. Okay, so we have our formula. So let's write this down here so that we can see it. So y is going to be equal to ln of a over p divided by our APR. So let's tackle the first question. How long would it take to earn $20? Well, so let's think about everything here. How much do we initially invest? I need to know our principal, and that is $300. Our APR is going to be 2.7%, which is the same thing as 0.027. Again, we shift the decimal place over twice to get this as a decimal. And then we need the money in our account. So if we earn $20, how much money is in our account? Well, if we started with 300, we'll have 300 plus an extra $20, right? So the money in our account is going to be $320. And now we know A, P, and APR, and I can plug them in and get Y. So here, Y is going to be the natural log of our account balance divided by our initial principal, and all of that divided by our APR. So let's come over to Desmos. So first of all, I want to take the natural log, and I can either type it in. I can just type ln, and it recognizes that this is a function, and then I would need parentheses. I want my account balance, which is 320, divided by our initial principal, and then I'll click over here to give that extra parenthesis at the end. So we have the natural log of 320 divided by 300, and all of this is going to be divided by our APR, which was 0.027, so 2.7%. And here's our answer, 2.39, but I want to round this to the tenths place, so that's going to be the 3, and I'm going to round the 3 up because of the 9. So it would take 2.4 years to earn $20. Cool. So let's do another one. So let's see how long it would take to double our investment. So again, our initial principal hasn't changed. We still invested $300. Our interest rate, our APR, oops, I will never not do that. Our APR is going to be the same, 0.227, as in 2.7%. But now our money in our account, now we're looking to see what happens when or how long it'll take to double our initial amount invested. Well, if you double something, we're multiplying it by 2. So this is going to be 300 times 2. So the money in our account after we double is going to be $600. And that's it. So let's solve for y. So y is going to be the natural log of the money in our account, which is 600, divided by our initial principal, all divided by our interest rate, which is 0.027. Instead of typing in ln, I will show you where the button is on Desmos to bring up ln. So the natural log is what's called a function. So if I click on function, I can see lots of kinds of functions here. I can take sines, cosines, tangents. I can do all sorts of things. Right here is the ln button, the natural log button. So if I click that, I can then start typing my numbers, which I would just go back to the main calculator to see all the numbers here. So what I had was 600 divided by 300. I need to come over here to be able to put the parenthesis in. And I'm going to take all that and I'm going to divide by our interest rate, which is 0.027 or 2.7%. So it would take this 25.6 years, except that I need to round up due to the 7, so it's going to be 25.7 years. And I shouldn't forget to include my units at the end. And let's do one more. So if our initial principal is the same as ever, 300, our APR, our interest rate, is the same as ever. But now our account balance, if we want to triple our account, well, if we initially have 300, we're going to multiply it by 3 to find triple that, which will be 900. And I can plug all this into my formula. So this is going to be the natural log of 900 divided by 300, and all that divided by our APR, which is 0.027. And the nice thing is that Desmos remembers what we put in, so all I need to do is change the 6 to a 9 to get 40.7. And that is our